Hello, I'm Lynn Bondurant, and welcome once again to our series about America's civilian efforts in air and space during a quarter century. During this sixth episode, we see NASA events from 1967 and 1968. 1967 is to begin in tragedy for NASA when on January 27th, 3 American astronauts die in a spacecraft fire during a pre-flight test. The men to die are Virgil Grissom, Edward White, and Roger Chaffee. A board of investigation finds that the fire is apparently started with an electrical short which ignites in the oxygen-rich atmosphere and burns combustible materials in the Block 1 spacecraft. Following the accident, the Apollo Block 2 spacecraft is completely redesigned and rebuilt. Though the delay is 18 months, the resulting Block 2 spacecraft is safer. But despite the tragedy, there is success in 1967 too.
There were 3 successful surveyors this year, helping prepare the way for Americans who would land on the moon. These 3-legged craft hurled 235,000 miles from Earth and sat down gently on the moon. Their job? Photograph large areas of the lunar surface. This the surveyors did, and more. Upon a signal from Earth, an arm on Surveyor 3, with a small shovel attached, extended out to this unknown soil, retrieved a scoopful, and placed it on one of the spacecraft's landing pads. Surveyor's camera then took a look at the moon material, in color. Other instrumentation has chemically sampled the soil. But the surveyors were not alone. 3 picture-taking lunar orbiters gave scientists a different perspective as they circled above the moon. Again, pictures. Pictures from a distance and pictures close up. Pictures revealing the lunar surface in remarkable detail. The kind of detail needed before men land there. Explaining what we've learned from the 2 spacecraft, NASA's Assistant Director for Lunar Flight Programs, Captain Lee Shearer.
There are 3 major accomplishments of the Surveyor and Lunar Orbiter programs. They have demonstrated that we have the technical competence to do a significant exploration of the planets with automated spacecraft. They have shown us that the moon is a complex and scientifically interesting place for further exploration by man. And they have paved the way for that first manned landing. This will be accomplished along the equatorial belt of the moon. In this zone, the 8 smoothest sites have been selected from orbiter photography. Into 4 of these, surveyors have landed. The next step is that historic moment when man first sets foot on the lunar surface.
It will be a launch vehicle like this Saturn V that will one day boost astronauts toward the moon. In this important first flight test on November 9th, all systems worked flawlessly. Separations occurred as programmed. Stages untried in space fired on command. Shown here in animation, the all-important re-entry to duplicate a return trip from the moon. It, too, exceeded its requirements. The spacecraft skipped in and out of the Earth's atmosphere to slow it down, blazing in at nearly 25,000 miles per hour, simulating a lunar return. Finally, a landing in the Pacific within sight of recovery ships. A textbook flight from liftoff to splashdown. Saturn V and its million component parts worked, and worked well. 1967 was an especially busy year for other unmanned space explorers. Biosatellite carried out the first biological research in space under controlled conditions. 13 experiments were chosen to study how various life processes are affected by the space environment. These earthly space travelers included frog eggs, wheat seedlings, wasps, and flower beetles. The main objectives of the mission were to study the effects of weightlessness and radiation upon living organisms. After 2 days in space, the biosatellite capsule re-entered the Earth's atmosphere. was snatched in midair by plane and rushed to Hawaii to waiting scientists. It was learned from the flight that several types of plants are dependent upon a continuous gravity field. However, most of the data from the various experiments, including those for radiation, are still being studied. 3 observatory-type spacecraft were launched during the year. This is OGO, Orbiting Geophysical Observatory. In addition to giving scientists a better understanding of interplanetary and galactic space, OGO's many experiment hours of data may eventually unlock some of the mysteries of the Earth's environment. 2 spacecraft in the Orbiting Solar Observatory series are studying the Sun and its influence on the Earth. The Sun is the nearest star to our planet and the only one we can study in detail. Here's an ultraviolet view as never before seen. It indicates solar heat in excess of 1.5 million degrees. Orbiting solar observatories will also serve as watchdogs for future space travelers, enabling those on the ground to advise astronauts of solar activity, warning them when they should come in out of possibly hazardous solar storms. The reliable Atlas Agena launch vehicle was used this year to launch the 2nd and 3rd in a series of 5 applications technology satellites. The spider-shaped spacecraft are being used to test out experimental systems for improving weather forecasts, radio, television, and communications of all kinds. Up till now, airplanes flying over mid-ocean have been out of radio range for periods of an hour or more. With ATS technology, airlines can keep in touch at all times.
And will you give us your latest ETA for London? Clipper 162, this is Goddard Test Control, over.
Goddard Test Control from Clipper 162. Roger. Loud and clear, a perfect signal.
This conversation between a Pan Am jet pilot and mainland United States took place when the plane was halfway from New York to London. The communication traveled from the ground to the satellite and finally to the airplane. ATS can also relay color TV and multiple telephone calls from around the globe. Color pictures of the Earth show the changing cloud pattern over the world for an entire day, giving weathermen a view in color of developing storms. While the ATS were checking out possible advanced application systems, NASA launched 6 more operational satellites, 3 ESA satellites for the Weather Bureau, and 3 Intelsat spacecraft for the Communications Satellite Corporation. On June 14th, a 540-pound spacecraft called Mariner was launched toward the planet Venus. After traveling through space for nearly 3.5 months and covering a distance of 219 million miles, Mariner 5 flew by Venus. The highly successful Mariner transmitted data about the Venusian atmosphere, ionosphere, magnetic fields, and the energy levels of cosmic rays. In Pasadena, the director of the Jet Propulsion Laboratory talked about the results. Here's Dr. William H. Pickering.
On October 19th of this year, Mariner 5 flew past the planet Venus at a distance of about 2,500 miles above the surface. This was the second successful Mariner mission to the planet. The path of the Mariner is shown by this model. And between these 2 points of the path around the planet, Mariner was out of sight of the Earth. This was done deliberately so that we could observe the effect of radio signals passing through the atmosphere of the planet Venus. By observing the effect of the atmosphere on the radio signals, we were able to learn a great deal about the atmosphere of the planet. To show, for example, that it is exceedingly dense at the surface, that it is mostly carbon dioxide.
NASA continued broadly applicable basic research in aeronautics during 1967. Supersonic aircraft technology was of particular interest. This effort included the operation of test planes like this XB-70. The XB-70 is being used to study the flight dynamics associated with supersonic speeds. The huge bird-like plane duplicates the size and speed of the SST. Although primary interest has been on materials, propulsion, and flight dynamics, work in such areas as fuels, radiation factors, and sonic boom is also continuing. One thing the XB-70 cannot simulate is the variable sweep feature of the SST, which allows the plane's wings to fold close to the fuselage for supersonic travel and then swing back to normal position for landing. The F-111 can, however, and NASA is using this plane to provide much of the experience needed to study the variable sweep characteristics of supersonic transports. To study speeds in excess of 3,500 miles per hour, the hypersonic X-15 rocket airplane is used. The usual jet black X-15 took on a new appearance this year, as it was painted with a special ablative coating to withstand the searing heat beyond Mach 7. On October 3rd, Major William Knight set a new speed record with the newly painted rocket plane, 4,534 miles per hour. As usual, the X-15 is carried aloft by a giant B-52. When the desired altitude is reached, the X-15 drops away and maneuvers on its own. Major Knight and all the test pilots at the Flight Research Center mourned the recent death of Major Michael J. Adams in a fatal crash of one of the X-15s, the first fatality since the program began in 1959. A so-called HL-10 lifting body was successfully tested this year at the Flight Research Center. Lifting body craft are being studied as one possible means of flying future spacecraft back to Earth after a mission, rather than parachuting into the ocean. Their stubby design will allow an astronaut to maneuver his spaceship back through the Earth's atmosphere and then land like a conventional airplane. Jet aircraft noise is a national problem. NASA's effort as part of a nationwide program with other government agencies and industry is threefold. While studies are going on to improve existing engines, the Lewis Research Center in Cleveland is designing a completely new engine, designed to be quiet. Across the country, at NASA's Ames Research Center in California, a specially instrumented jet is being operated in a way to decrease the ground exposure to noise. This involves flying the plane in at a steep approach and letting the distance reduce the noise on the ground. Eventually, all the known noise control techniques will be combined in an effort to produce a truly quiet engine.
1968 is a better year for NASA. America, in effect, wins the space race when 3 American astronauts safely orbit the moon. NASA does planetary studies too.
The moon, not nearly as mysterious as it used to be, has been photographed, landed on, dug into, and chemically sampled. Surveyor 7 was the last in a series of unmanned spacecraft to land there. Reflecting on Surveyor's contributions, Dr. William Pickering, Director, NASA's Jet Propulsion Laboratory.
Surveyor accomplished everything that we had hoped for from that mission. 5 out of the 7 Surveyors which were launched landed successfully on the surface of the moon and operated on the surface. With the Surveyor photographs, we were able to show that landing a manned spacecraft on the moon is quite a reasonable undertaking, and in fact that the man will be able to walk on the surface of the moon without danger of falling through or sinking into the dust at any great depth. We were able to measure the bearing strength of the surface. We were able to get the general appearance of the surface, to point out that in certain areas of the moon at least, there were not very many large rocks which have to be contended with, but there were, of course, numerous smaller and smaller craters. We also found the first chemical analysis of the surface of the moon by Professor Turkovich's experiment. And this showed that in the areas that we landed, the rocks, or the surface material rather, was very similar to a basalt here on the Earth. We were also able to dig in the surface and get an idea of the feel of the surface as we went down a little bit below the surface. For a matter of a few inches, the material is very much like a soft sand to dig in.
JPL is also applying its scientific know-how to Mars, flying by initially, landing and testing in the future. The experimental model of a wheel-shaped planetary landing craft is one of several landers being considered. In an effort to learn more about the possibility of life on Mars, the lab again sent a scientific team to the Antarctic. Carefully collected soil samples in this and other desert areas were returned and subjected to rigorous analysis. The sun, seething and turbulent, affecting every living thing on Earth. By studying it, we can learn more about our own environment. Interplanetary Pioneer spacecraft are doing just that. 2 were launched in 1968. At one point in their voyage millions of miles into space, they passed directly behind the sun. The data being returned is helping improve weather forecasting and adding a measure of protection to moon-bound astronauts by forecasting solar activity. Also helping us learn more about the Earth's environment, Orbiting Geophysical Observatory, OGO-5. By studying such things as our magnetic field and radiation belt, solar flares and solar wind, we gain new insight into the complex Earth-Sun relationship. Radio Astronomy Explorer, one of 5 Explorer-type spacecraft launched. Here, Dr. John Findley, Chairman, U.S. Lunar and Planetary Missions Board, explains its job.
An important project of the Office of Space Science and Applications this year is the Radio Astronomy Explorer satellite. While ground-based radio telescopes, such as this 140-foot instrument, can observe at the short radio wavelengths, the Radio Astronomy Explorer will make its measurements at wavelengths of several hundred meters. In fact, beyond the edge of the radio window. From the results of this satellite, we shall make maps of the brightness of the radio sky. And these will help us find out how our own galaxy generates and radiates radio waves.
The heaviest and most sophisticated satellite to be launched in 1968 was the Orbiting Astronomical Observatory, OAO. The Earth's atmosphere limits and distorts the stars viewed by astronomers from the ground. But OAO rises above all this. Its 11 telescopes are viewing the stars with a clarity never before possible, mapping the skies and providing a better understanding of the origin of the solar system and universe. Shortly after launch, Nimbus B, an experimental weather satellite, plunged into the Pacific just off the coast of California when a gyroscope malfunctioned. Divers recovered 2 valuable nuclear-powered generators about 300 feet down. Advanced research and technology moved ahead on many fronts in 1968. The wingless HL-10 lifting body made 13 flights, including 2 with sustained rocket propulsion. The flatiron-shaped craft gets its aerodynamic lift from the wingless body shape. Lifting bodies show promise as reusable spacecraft of the future, spacecraft that can land like conventional airplanes. After 9 years and nearly 200 flights to the edge of space, the rocket-powered X-15 program was brought to a close with 8 final flights in 1968. The half-plane, half-rocket X-15 has been a unique flying test bed for researching aeronautics and space problems. The giant XB-70, flying at 3 times the speed of sound, made 13 research flights, gathering data for use in the development of large supersonic aircraft. NASA also conducted extensive flight studies on several types of vertical takeoff and landing planes. VTOL, as they are called, are craft that can rise vertically, then fly forward like any other airplane. VTOLs may one day be used as intercity transports, improving short-haul air transportation. Much aeronautical research is done with models. In this particular test, a highly instrumented model is dropped from a helicopter, then flown by radio control from the ground. This type of study makes the most rigorous test possible without endangering valuable planes. Jet aircraft noise is a continuing national problem. NASA has been attacking the problem in two ways. First, by attempting to design a new, quieter engine, and second, by modifying existing engines so they make less noise. On this plane, engineers at the Lewis Research Center in Cleveland are trying out various engine modifications to determine the effect on the plane's performance. It has been found that by cutting grooves in airport runways, planes landing on rain-soaked surfaces can land with less chance of skidding and stop easier. These studies were continued in 1968. Some of the braking tests were made with specially instrumented cars on the grooved runways. The results now appear to have application to highways as well as airport landing strips. At the Nuclear Rocket Development Station in Nevada, NASA, in cooperation with the Atomic Energy Commission, test-fired a powerful nuclear rocket reactor. The tests are part of an effort to develop nuclear-powered rockets for future deep space exploration. Apollo can be likened to a finely tuned watch. Men and space machines are perfected to the highest degree possible. In most cases, the astronauts who fly the spacecraft train separately, but concurrent with the build-up and development of the space machines themselves. When brought together, they must mesh smoothly. There is little room for error. Apollo is like this, and the men who fly and the men who build know it. There were 4 Apollo flights in 1968, 2 unmanned, 2 manned, all part of the preparation for moon landings. Apollo 5 sent aloft to check out the lunar module. It is in a lunar module that 2 astronauts will land and take off from the moon. Both the descent engine, used to slow the spacecraft for the landing, and the ascent engine, which will boost the pair off the moon, were successfully tested. To further ready the Saturn V rocket and its many components, the unmanned Apollo 6 was launched into Earth orbit. Engineering cameras on board recorded the first stage and interstage separations. After 10 hours in space, the command module was rammed back into the Earth's atmosphere, simulating a lunar return, another milestone in preparing for moon missions. The next step, check out the spacecraft with men aboard. Here, astronauts Schirra, Cunningham, and Isley move about weightlessly in their Apollo 7 spacecraft. This was also the first full-dress rehearsal for the manned spaceflight tracking network. 14 ground stations located in such places as Bermuda, Australia, Spain, and Hawaii, together with planes and tracking ships, kept a constant electronic ear tuned to the Apollo spacecraft. After 10 days and 163 revolutions, Apollo 7 splashed down in the Pacific, paving the way for the first half-million-mile journey to the moon and back. From Launch Complex 39A at Kennedy Space Center, the Saturn V rocket boosted Apollo 8 astronauts, Borman, Lovell, and Anders toward their rendezvous with the moon. The first time the big rocket was flown with men as passengers. While en route, the crew kept busy checking and double-checking all systems as they sped toward the moon. Many of the things they did will have a direct bearing on future lunar missions. Nearly 3 days and 230,000 miles later, the crew of Apollo 8 fired their rocket engine, placing them in lunar orbit. Here are some of the views recorded by the crew as they orbited the moon 10 times. Views from afar and close up, showing remarkable detail. The kind of detail needed before men land there. Then the cameras and spacecraft were turned toward Earth. and after 3 days and a fiery re-entry, landed in the Pacific within sight of the recovery ship. Apollo 8, final flight of the year, historic prelude to lunar landings and to the peaceful exploration of space in the future.
Those are some of the NASA highlights of 1968. During our next episode, we cover the years 1969 and 1970 when NASA lands men on the moon and returns them safely to Earth. I'm Lynn Bondurant.
Roger, Columbia on a roll. Columbia, Houston, you're go at 40.
Roger, go at 40.